Okay, well, good morning, ninth grade. I hope you all are doing well. We are now on a new lesson, 10.4, and we are on what's called special patterns. Okay, and with special patterns, we're going to see something different. It's going to be similar to what we did before, but it's going to be a little different. So I'm on page 420. Okay, so I'd turn there because you're really going to want to pay attention, especially to this first formula. Okay, we're going to call this, if you remember this from one of our last sections, we had something called the difference of squares, okay? The difference of squares. The way this works is that if we have, as you see there in your book, a squared minus b squared, what that comes out to is a plus b and a minus b. Okay, that's very important. This formula right here that I'm circling in red, you need to write it down and let it sink into memory, okay? What that means is if you have a squared here and a squared here and a negative sign in between the two squares, you see that? Squares, there's two of them. Difference, there's the subtraction sign. What that translates to is one of them becomes a plus b, so one of them plus the other, and then the other one becomes a minus b, one of them minus the other. Okay, that's just a rule in algebra. Okay, so if you need to pause it and write that down, go for it. So let's see, how does that work practically? Well, if you're with me on example 1, we have x squared minus 49, okay? 49, we see this is a square, right, of 7. X squared is obviously a square of x. And then look at this, we got our negative sign. So we have a difference of squares. So all I do is I take this x and I write it x and x, right? And I know one's going to be minus and one is going to be plus. That's what the formula tells me. I can do that right away. I take the square root of x squared, which is x, and then I put a minus sign. So right here, x minus, x plus. You can do it in any order. It doesn't matter. Then I look up here and say, what is the square root of 49? And the answer is 7. So my final answer then looks like this right here. X minus 7, x plus 7. That is the difference of squares. Okay, not super hard at this point. It's going to get a little harder, though. That's example 1. If you're still tracking, here's example 2. 5 minus 125 x squared. Okay, now the key part is that first I have to factor and take out what they have in common. I have to do the inverse of the distributive property. So what do they both have in common? Well, they both have a 5 in common. So I divide by 5, and 5 divided by 5 is 1. 125 divided by 5 is 25. Okay, now that the 5 is out here, inside here, I have a difference of squares. Now you may say, how is 1 a difference of squares? Well, 1, think of it, 1 squared is 1. The square root of 1 is 1, right? So we can always use the number 1 in these things. Very important to keep in mind, okay? Then let's look here. We have our negative sign. And lastly, we have 25. That's a perfect square, right? 5 times 5. And x squared, which is also a perfect square of x. So now all I have to do is rewrite this. I keep this 5 right here. I keep the 5, and I go, this time I have 1 minus something, and then I have 1 plus something. Okay, just like I did last time. This 1 is going to go to this place, minus something, plus something. Okay, just like the last example. Same exact thing. Except for now, I say, what's the square root of 25? Well, that's 5 and 5. And what's the square root of this x? X and x. So that means that this whole thing right here is my complete answer. 1 minus 5x, 1 plus 5x, all of that in parentheses, and then times the 5 that we pulled out at the beginning. Okay, that's not too bad. Now, if you're still with me, look up to example 3. So this is example 3. And that is on page 421. Okay, so please follow along. We have 36 x to the 6th z squared minus 64 y squared. Okay? Now, again, the first step is to say, what can we pull out that's in both of them? Well, if you look there, they're both divisible by 4. So I divide by 4, and I get 36 divided by 4 is 9. So I get 9 x to the 6 z squared minus 64 divided by 4 is 16. 16 y squared. Okay, now I'm going to find the difference of squares. You see this 9 is a difference of squares, 3 and 3. And 16 is the difference of squares, 4 and 4. And then look, x to the 6th is going to be x to the 3rd and x to the 3rd. Z squared is going to be z and z, right? I'm just splitting them in half. Okay, with the exponents, I'm splitting them in half. And y is just going to be, or y squared is going to just be y and y. So I come down here, the 4 stays, and I write 3x to the 3rd z. You see I reduced all of them? I took the square root of all of them. And then I do minus, okay, and then I'm going to do the same thing, 3x cubed z plus, now I just do the same thing with this, 16y. What is 16? The square root is 4 and 4, and I have y and y. So that's my final answer. 4 times 3x cubed z minus 4y, parentheses, and then parentheses again, 3x cubed z plus 4y, right? So this is my final answer down here in the black that I pointed with red arrows, okay? So not too bad. I think you guys can do it. I wanted to keep it a little more simple for you. So actually for this weekend, this is going to be our only homework that we're going to work on, okay? So all the problems are going to be like this. I'm going to do one more just so you get used to doing it, okay? And then we'll go with the homework problems. So another one would be something like this, 2x squared minus 128. Okay, you see here, this is an x squared. So we know there's a squared, and we don't know. That's not a squared, but guess what we have? We have a 2 that we can divide by. So I do 2 divided by 2, and I get 2, and then I get 1x squared minus, and we type in 128 divided by 2, you get 64. And that's the number that we want to see because 64 is the perfect square of 8. So I come down here and write 2, and then I just do the same thing. X, and I know that one's going to be plus and one's going to be minus, right? Because I took the square root of x squared, and I got x, and now I take the square root of 64, and I get 8 and 8. And there, ladies and gentlemen, is my final answer. Okay, not too bad. Now let's do one that's a little more complicated here. And then I will let you work on the homework. So let's do this one right here. 81 a squared minus 36 c squared. Okay, now there's nothing that they have in common, right? Well, they do have something in common, sorry. What we look at first is say 81, that's a square, and 6 is a square, but they're not the most reduced as what they could be, because they both have a 9 in them, right? This is 9, and this has a 9. So we pull out the 9 first, and we divide by 9, and I'm left with 9a squared minus 4c squared. Okay, do you see that? 81 divided by 9 is 9. 36 divided by 9 is 4. Now that I come down here, I rewrite this as 9 outside, and I do, what is the square root of 9 is 3. What's the square root of a squared? A. And I know one's going to be plus, and I do 3a again, this time minus because I used it. And then I come here, 4 is going to be 2. The square root of 4 is 2. And then I come to c squared, and the square root of c squared is just c. And there is my answer for this problem right there, okay? Just for good measure, let's do one more, final one, so you get more used to it. Let's do 49 x squared minus 81. And when we look at this one, there's nothing they have in common, right? This is 7 times 7, and this is 9 times 9. So I'm just going to go straight into it. I'm going to say this is 7, right? The square root of 49 is 7. The square root of x squared is x, so I get 7x, which means we have 7x and 7x. Then I take the square root of 81, and I get plus 9 and minus 9. Right? It doesn't matter which order those are in. That's your final answer. Okay, so here's the homework for today. Pretty straightforward. It is on page 422. This is 10.4. And we're going to be doing numbers 1 through 10 all. Okay, they're not very hard. And then we're going to be doing, pay attention to these, 13, 14, 21, 22, 29, 30, 33, and 34. Okay, it's kind of a weird number combination down here. 1 through 10 are very straightforward. And there's one spot where you just have to write whether or not they are a perfect square. So on 7, or I'm sorry, it's not 1 through 10 all, my bad. It's actually 1 through 6 all, even less than you thought, right? 1 through 6 all, okay? So hopefully you stayed with me there. only 1 through 6 all, and then 13, 14, 21, 22, 29, 30, 33, and 34. Okay, good luck. You have all weekend to work on this, and then we'll work on the second half of the lesson. Mr. H. So over and out.